It's a low-level fundamental primitive for the web that we can use in all sorts of exciting ways now, and I don't think we've even touched the tip of the iceberg.
This idea has been as almost as old as the web. I like this has been something that's been in the background since there's an RFC from 2003.
It feels a lot like bringing SPA type architecture to MPA pages, right?
Today, I'm doing something a little different. I wanted to talk through my journey implementing compression dictionaries, but then I thought, why not invite the two gentlemen who are responsible for bringing them to the web to discuss it with me? These guys shouldn't need an introduction as they are both veterans who've contributed so much to the web that we should be grateful for. But just in case, we have Yoav Weiss, a principal engineer at Shopify who previously worked at Google and Akamai. If you've ever used the picture HTML element or source set, you can thank Yoav for making those a reality. And we also have Pat Meenan, a senior staff engineer on the Chrome team at Google. Pat previously worked at Cloudflare, Meta, and if you go way back, AOL. And if you've ever used web page tests to run performance tests on your website, then you can thank Pat. Let's get into it. So, Pat, we have your article, Getting Real Small, on the Perf calendar, and you gave a talk a couple of years ago at Perf Now, introducing compression dictionaries. Can you give us like an elevator pitch, like 60 seconds? What are they?
Sure. I mean, probably the easiest way to put it is it brings delta compression to the web. That can work in largely two ways. In-place updating of JavaScript, for example, where you or CSS and that kind of resource where you deliver just the things that changed from the previous version. And the other place where it can work is you can have a standalone dictionary that you can then delta compress arbitrary content against. And the main case that I've generally used it for is HTML pages, where you can put all of the common template stuff into the dictionary, and then all you're really delivering on each page load is just the stuff that's unique to that page. But it also applies to APIs, and so it's a general framework for delta compression with HTTP resources. So I'm mostly excited to see the interesting hacks and things that people do with it.
Awesome. So how does this kind of differ, I suppose? You mentioned kind of delta compression. In terms of the kind of file sizes we're looking at, how does this compare to like a Brotli or a GZIP?
So it largely depends. Kind of the mantra of the web, right? In performance, it depends on how much changed. So JavaScript files, if you're releasing frequently and you have like a one-line code change, it'll take what's usually like a 50-60% compression just by using Brotli or whatever by itself. It'll save another 90+% of the file to basically deliver just the thing that changed, but that thing is also Brotli compressed or Z standard compressed, right? So it's like the absolute smallest bit that you can send to represent the bit that changed. And in cases of like HTML, again, it depends on how much of the page is templatized standard stuff versus content. Like if you have really long form articles and blog posts like wiki pages and things like that, where there's a little bit of a shell and a whole lot of content, you'll still get faster initial renders because the stuff that tends to be common is all of the invisible stuff in the head and the header of the page and the things that you need to get initial render. And so the overall compression may not be quite as important, but you'll get like 50% additional savings on top of Brotli alone, anywhere up to the 90 plus if you've got like a bunch of product pages that all have a lot of structure that looks the same, and it's really just the product description and the product images, which are side-loaded anyway.
Yeah, I was going to say,
quite a range.
Like Wikipedia, for example, they've got a very lightweight website already, for example, but when it comes to e-commerce, most sites have those big kind of mega navs, right? So, that's going to be duplicated on basically every single page. So effectively, are we saying we can kind of strip all that out, basically?
Yeah, And I think it might have even been Yoav that came up with the analogy, but it feels a lot like bringing SPA type architecture to MPA pages, right? Because now for full navigations, you're really just delivering what you would in a SPA. The you're not delivering the framework or the application shell. You're delivering just the part that's unique to the page that you're visiting. And so it gives you the effective lightweight nature of a SPA without having to change an application and still get the clean navigations and everything else that you get with a multi-page app.
Awesome. And I suppose that kind of links back to that kind of start render time. You kind of touched on it in terms of, how does this, given that videos and, images are such a large amount of bandwidth, saving a few kilobytes here and there on your HTML might not mean much, but it can drastically change that process because nothing can actually happen until the HTML's arrived, right? Or it's started to stream down at least. So getting that as small as possible means that we can discover those resources very, very early on. And rather than having those kind of staggered waterfalls, we can stack it a lot more vertically, and the browser can be a bit more intelligent about how it requests things, right?
Yeah, and I mean, probably just as importantly, the rule of thumb doesn't really hold anymore, where it was like the first 15K of your page can be delivered in the first round trip without having to make multiple round trips on the latency, for example. With HTTPS and CDNs, that's not quite the same number anymore necessarily, but what this does give you is it gets you a lot more content into that first round trip, where you can more likely than not deliver everything you ever wanted in your head, as well as some of your initial content in the first round trip without having to make multiples. And so that no longer becomes a bottleneck in the rendering.
Awesome. So, Yoav, could you maybe tell us a little bit about the history? Like, how did this idea come about?
So this idea has been as almost as old as the web. This has been something that's been in the background since there's an RFC from 2003
Oh
on
wow.
delta compression and how it can be deployed, only that it couldn't. There were a ton of problems with proxies, a ton of problems with introducing new status code and whatnot into old intermediaries, and that older version never actually got deployed. Browsers never implemented it. Then a few years later, compression in general became more complex due to new discovered vulnerabilities around essentially being able to sniff out secrets from encrypted connections through compression. Those family of attacks is called like breach and crime, and they made every attempt to touch on compression at the protocol level very complex and fraught. One of my first stabs at in the standard world was around Speedy and trying to introduce intra-frame compression there, and that was shut down because of these that was a few months after these vulnerabilities were discovered, and it's like, no kid, that's not going to happen. So after that, Chrome shipped SDCH, which stands for Shared Dictionary Compression over HTTP, I think. And Pat can probably tell us more about all the problems that were involved in that, but at least from the outside, so it was less functional version. It only included the dictionary, like download the dictionary ahead of time and out of band version, rather than the delta compression one where you can upgrade in place. And so it was less useful from my perspective at the time, and also from, everyone that is not a very large site with a lot of repeat visits that can amortize that out of band dictionary over time. It also wasn't well integrated with Fetch. It had a bunch of issues, and eventually it got removed from the code base and unshipped in Chrome, in Chromium browsers, I guess. And then I guess the next step after that was a proposal I had back when I was at Akamai, shared with Cloudflare folks on being able to essentially go back to like cross-frame compression and being able to apply compression across different streams in HTTP2 and HTTP3. And that was again shut down for security reasons. We tried to make some arguments about why the security reasons are not valid if we just touch on CORS resources because they're readable anyway, but the protocol layer has no idea what CORS is. So that was the wrong venue and the wrong layer for that kind of a solution. And then eventually, back when I was at Google, some discussions came up around ways to Delta encode. I think the original use case were for large WASM bundles, but essentially, again, the same discussion came up, but now, at least from my perspective, that was the right layer to say, okay, here we can apply these solutions to cores only, and all the security vulnerabilities that we had in the past, if we just make sure that both the resources being compressed and the resources that are being used as dictionaries are all fully readable, then we don't have a problem with, attackers being able to sniff out secrets from them because they're fully readable anyway. So that's essentially what unblocked Delta compression this time around.
It sounds like you've been quite a journey there. So is this something that we can use today? Like, I did some analysis with Barry Pollard on the HTTP archive, and I found that there's only a handful of websites that actually use this today. I mean, if you count individual Shopify sites, then it's a lot. But if we count that platform as one user, then I think there was something like 13 or so others outside of Shopify and Google. So what's holding back the adoption here? Is it education? Is it browser support? Like, where do we stand today?
So I think deployment complexity is probably the main bottleneck, right? So it's not a flag that you can just flip to turn on compression, basically, and there's some work involved. The amount of work depends on what you're trying to do with it, and so I think the real unlock is going to come when CDNs and web servers adopt some form of native support for compression dictionaries. And so once that happens, I expect you're going to see it ramp up really quickly. Until then, you basically have the companies that have the resources to do the server-side engineering to generate the dictionaries and to do the delta compression themselves, since it's not being done automatically at the transport layer by their platform that they're on, and that have enough benefit shown from performance improvements to justify the engineering work that they're doing, because it's a non-trivial amount of engineering. It's not a huge amount of engineering work, as you saw when you experimented with it, but it is engineering work that takes some level of skill that's taking away from feature development. And so there's always that play-off between performance work, feature work, how much effort do I put into it, and as we start getting more adoption, I think you're going to start to see that ramp up faster. Certainly once CDNs pick it up and it becomes more of a checkbox kind of a thing, then you're going to see pretty big jumps.
I think that even like a step before that is for CDNs to just pass through the traffic and not get in the way. And right now is an upstream battle across, like, I haven't tried all platforms, but across many platforms, it's an upstream, like, it's an uphill battle of trying to get it in place despite the CDN.
Is this the accept encoding header flowing through because many CDNs normalize that?
That's one. The other is requiring custom cache keys, which is fine, but required some, you know, some research and some convincing, and like none of this just works out the gate if the origin supports it.
So you have to tinker at the CDN level.
Yeah.
And I presume there are many CDNs out there that only offer the very kind of productized feature sets. I know there's companies like Fastly that support quite low-level coding with VCL, but many do have that kind of checkbox approach. And if it's not a checkbox, then you can't really configure things. So I presume that's a barrier to entry there currently. But having spoken to a few people at some CDNs, there are people already looking at implementing this. So hopefully we'll see some movement soon. So on the browser side, Yoav, I know you've been working on this. Where do we stand in terms of giving this benefit to real world people? Like, I know it's in Chrome, but where are we at with Firefox and Safari?
So it's in Chromium. So I believe like at least most Chromium browsers have support. I don't know if some of them turn it off, but for Firefox, they almost shipped support, and then there was some scenario, also at Shopify, but not only at Shopify, if I understand correctly, where a cache hit for a response that dictionary compressed itself was causing their dictionary compression logic to freak out. So they now, I believe that it's fixed and on its path to being shipped in the next release. I don't remember the numbers, but like essentially Firefox are very close to shipping. And rumors are that Apple also have some implementation in place, but are hesitant regarding the justification for the work. So essentially, more sites adopting would create an incentive for Apple to ship.
So we all need to go out and start implementing this on our sites as much as possible, basically.
Yes, but not just add DCB support or DCZ support, but essentially make it work and make it work well, so that they will feel the pressure.
Yeah, once it becomes a competitive disadvantage, right? At that point, then it becomes something that they're incentivized to ship.
So Yoav, you touched on making it work well. Do you mean from a kind of compression and visitor user experience side of things, or do you mean more kind of? I know there's some rough edges around things like tooling.
No, I was talking about user experience. If we can easily show the world, and Apple engineers included, that sites are significantly faster in browsers that support compression dictionaries versus browsers that don't, for repeat visitors and all these caveats, then we'll be able to make the case for them to ship whatever it is that they have, like improve on it and ship it.
Okay, so we just need to apply some pressure then. Yeah. Cool. So in terms of making the most of things, Pat briefly touched on the different implementations. So we've got upgrading the same resource, for example, like on a repeat view, if you've rolled out a new release. We've got serving a standalone dictionary for kind of across page views, or I guess even within a page view if something is loaded late. There's the instance where we use the actual resource as a dictionary to compress another. And then there's the final one, which I don't think we've touched on yet, which you wrote an article on in December, where you actually use a resource, in this case a CSS style sheet, to compress the standalone dictionary. Can you just talk about the driving force behind that idea and like what do we gain from doing that?
Essentially, this is, at least from my perspective, the first use case for compression dictionaries that doesn't just touch on repeat visits, but also on follow-up pages. Although, like an out-of-band dictionary, if it loads in the first view, it also does that. But essentially, what we gain from this is the ability to, at least in the case of CSS, deliver the required CSS for each page without suffering from the cache downsides that that approach used to have. So back in the day, we said, okay, just deliver the critical CSS for each page and then just inline the CSS that's needed. But then every page has to download all of its required CSS from scratch. There is no shared cached resource. The other extreme of that is let's have one big CSS file that includes all the CSS that any page on the site will need, but then you're penalizing the first view. And you need a lot of like deep sessions in order to amortize that, and still like the first view is a critical view. The approach of the approach I described in the article is essentially it enables us to deliver only the required CSS for the first page, then deliver the dictionary as a delta from the full CSS to this CSS that we already delivered. So we're not wasting any bytes. We're delivering the full CSS, but at idle time as a dictionary. And then every follow-up page, every same site navigation following that is using that dictionary to deliver its critical CSS. So essentially on the network, we see very little payloads. So in the order of like hundreds of bytes other than the headers. So essentially we're just paying an RTT. But in terms of processing, every page only needs to calculate the styles for the critical CSS that it actually has to deal with. So in terms of processing, no page has to deal with the full CSS and all the rules that it doesn't have to bother with.
So you could, for example, build a collection of style sheets based on page type, which include the global styles and anything that's specific to any component that could be used on that page, but then exclude anything that might be in like a different section.
Yeah.
So let's take a Shopify example. Your styles for your product listing page, you might bundle those into one style sheet with the kind of global styles. Then you might have your product detail page, and those styles are going to be bundled with the global styles as well. So you end up with these two style sheets, but neither needs to have knowledge of each other, rather than creating one enormous style sheet. And then that way, just say someone lands on a product detail page, they've come in from Google Shopping or something like that, and they've landed straight onto a product, and then they go out to a product listing page to browse more. On that initial page, we get just the styles we need for that page, or that page type, should we say. And then we load the dictionary, which includes every bit of CSS across the whole website, right? But we actually compress it using that page's style sheet. So that way the dictionary is only a really tiny file as well, because it only includes things that are not already on that page. And then when we go to that next page, we've already got the dictionary, it's already got the global styles and the entirety of the site's CSS. So it's just about picking out those tokens, if that's the right term in terms of compression, and unbundling that second style sheet from the dictionary. Is that correct?
Yeah, and I mean, this sort of touched on it, but it's kind of exciting that it fundamentally changes what inlining content means, right? So it effectively lets you cache in the dictionary things that are inline in your pages. And so for this example, you could inline all of the CSS that's needed specific to a given page and still pull it out of the cache from the dictionary effectively. But with things like Google Search, what they did was they inlined the SVG logo for the Google logo in search because it's much faster. But they also got the benefit of it being cached, which is why they used to use an external logo, because now that SVG is in the compression dictionary. And so you get that kind of hybrid where you get the cache benefits of it being in the dictionary, and you only include what you need to include, and you no longer have to do an extra round trip to fetch the external CSS or scripts or whatever you've inlined. And so it kind of fundamentally changes how pages could be structured or should be structured, which is kind of exciting, kind of scary. Things like inline data URIs for placeholder images are no longer expensive if they're like blank images or whatever a common set, because those can be in the dictionary.
I'm so glad you touched on that, because that's literally what I've implemented on Lessons of a CTO. I've just inlined the CSS for that because I can now compress across pages rather than each individual page. It means that, yeah, there's a little bit of a hit on the first page, but ultimately we need styles to render anyway, so it avoids that round trip, as you say. And any subsequent pages, it's already sat in the dictionary. So I've been able to do the exact same thing, taking cues from the discussion with Yoav in terms of the approach for CSS. I use my actual HTML to compress the dictionary, and then I can do the reverse, where subsequent HTML pages are using that dictionary.
Even without the complexity necessarily of using the HTML to compress the dictionary, you could weigh and see how much that actually shaves from the dictionary itself, just because the loading of the dictionary, in as much as possible, is done in idle time in the browser passively, so it's not critical line of blocking, and so you're not trying to amortize as many bytes. It's nice from a technical perspective, but if there's complexity, like there's multiple routes into your landing page where people might have like 20 different HTML pages, you don't necessarily want to compress the dictionary across every possible landing route. Maybe just do a couple, maybe it doesn't matter. It's going to be interesting to see kind of where in that line things pan out, but it's exciting that you can as well, right?
Yeah, I think it took my dictionary from something like 40 kilobytes down to just 15, if I remember rightly. So it was a significant saving, but like you just said, it's downloading out of band. So it's not something anyone is going to visually appreciate. It's more just being respectful of people's bandwidth as much as possible. But then, maybe it's a little overkill for a video site, given there's going to be some pretty big files there, I really just wanted to kind of give this a go and see where those edges are, like experience how easy it is for other people to implement, and for me to be able to advise clients and whatnot as well. So I suppose that leads me on to Footguns and things like that. I wrote up my approach again in December for the Perf Planet web performance calendar that Stoyan graciously releases every year. And there are a few things that I kind of found challenging, so I'll share those things first, and then maybe we can hear from you guys. So the key bit, and we touched on this from the CDM point of view, is that we need to persist dictionaries across releases. I was using Netlify's platform for this, and figured out I'll have to save my dictionaries in their blob storage and ensure that it doesn't wipe it out upon a new release. So that way, if someone comes back to the website, they get the benefit from that dictionary compression because the server actually has knowledge of that old dictionary. So I guess that's one thing that you need to look at in terms of your architecture. And then the second piece, again, depending on the services that you're using, is around how you save the response bodies. Really we want to compress them and have the edge save them somewhere, ideally distributed as much as possible. So it's not just the case of that one node in that one point of presence having a copy and then the others having to recompress elsewhere. So maybe we start with you, Yoav. I know Shopify have implemented this with Shopify checkouts. Are there any learnings from that?
One of the hardest parts that I didn't have to deal with is making sure that bundles have stable semantics over time. This is something that is notoriously hard on older bundlers. But essentially when I got to Shopify and started poking around, they already moved to Vite and Rollup, and making sure that the semantics are stable was very easy, very intuitive. But in places where this is not the case, I think this is the first struggle. And the reason it matters is that if you don't have stable semantics for your JavaScript bundles or CSS, that means that for every new release, the code will get reshuffled in ways that even if you have all the other pieces in place and you can compress one file using the previous file, the difference, the delta between the two will be very large because those semantics weren't maintained, and you basically get random JavaScript code that is unrelated to the previous version.
So just for anyone who might not understand what you mean by semantics, are you describing where code lives in separate files and the kind of naming of those files, or?
Yes. So main.js and header.js and footer.js or whatever need to remain the same conceptual code over time. And all the modules that went into one should continue to go into the other than the changes that are, naturally occurring over time. But if you have bundles that are not that, and the bundler decides to split modules based on its own internal heuristics that aren't related to the way that the code is authored, that's a recipe for a bad time.
So effectively, people need to look at, if they do a release and they change a small amount of JavaScript, let's say, what's the actual change in the build output? Like, has all the chunks of JavaScript completely changed, of all the file names changed, or is it somewhat aligned with what they actually see in their source code diff effectively?
Exactly. And the other variant of that is minifiers that are, so it's the same semantic code, but all the variable names changed because you changed one line of code. So that's also another typical gotcha that folks should watch out for. Again, it's not like this is less awful and it's not going to kill all your benefits, but it's definitely going to add, unnecessary churn to the Delta actually being downloaded.
Pat, anything from you? Are there any insights from Google or people that have been implementing this that you have visibility of?
I mean, I think sort of touched on it a little bit with Yoav's answer, but the tooling is kind of the sore spot right now, right? And so hopefully as adoption grows, bundlers will get smarter and actually build things knowing that dictionary compression is a thing. But even just the tooling for generating dictionaries and delta compression files and having access to Brotli and Z standard dictionary compression in streams from your server, for example. Like when I was doing experimentation on a CDN using Workers kind of a platform, I had to do my own WASM Brotli build to get dictionary support, right? And so it'd be nice if, and it is starting to, I think like the PHP Z standard extension now supports dictionaries natively. But so just getting those APIs rolled into higher and higher layers and the command line tooling for creating delta compressed files. Right now there's a special header you have to add manually just because the command line tools for Brotli and Z standard don't natively speak the DCB and DCZ content or file formats yet. Both have expressed interest in adding support. It's just, it hasn't been done yet. And so I think that's probably the biggest pain point right now is just the first thing everyone trips on is they'll create the Delta compressed files using the command line tools, forget to add the header, and they'll get an error in Chrome saying dictionary mismatch or something along those lines.
That's something that I've personally experienced. And to clarify, by the header, you mean those magic bytes at the start of the file that have to be in place to indicate this is the correct format, right? So yeah, I very much hit this as well. Hopefully we'll see something from those native tools that will help improve the situation. My article that I wrote back in December covers a lot of that in detail, so I'll definitely link that below amongst all of your articles, of course. So just to wrap up, do either of you have one final thought for our audience to leave with? Pat, maybe you could go first.
Yeah, I mean, I'm mostly just excited, and my talk from 2 years ago was along the same lines. I'm just really excited to see what people can do with it. Hugely grateful to Yoav for actually cracking the egg and doing the hard work on figuring out how we could do this. But it's a low-level fundamental primitive for the web that we can use in all sorts of exciting ways now, and I don't think we've even touched the tip of the iceberg. We've hit like the super basic easy use cases, but there's going to be all sorts of interesting use cases. And it's not specific to the web either, right? It's HTTP level, and I've been seeing native apps picking up support for it as well because using it in JSON-based APIs, for example, is a dead easy case where all of that JSON cruft that goes into your normal API calls and responses can go into a dictionary effectively and almost turn your JSON into a protobuf level efficiency by compressing out all of those keys and standard values and things like that. And so I'm excited. It feels like it's going to be a bit of a long burn to get to the end state, but I'm excited to see where that takes us.
That sounds like a really interesting use case. I definitely want to give a go. Yoav, do you have anything that you'd like to wrap up with?
I hear a lot of people complaining about, oh, but what about Apple support, Safari support and whatnot, and it's a chicken and egg problem, and we just have to deploy, have to find all the interesting use cases that Pat talked about, and get the very real and transformative benefits that the compression dictionaries have today for real life websites. It's a bunch of work. It requires a lot of, you have to be stubborn and you have to work on it and make it happen. But once you do, there are a ton of benefits, and those benefits will only grow over time with more support from browsers, being able to shed some of the technical debt once CDNs and other platforms get better support. So it's a bit of a hard work up front, but it's worth your while. So people should just go ahead and do it.
Yeah, I think in terms of users of the web, we're at like 75% Chromium overall. I mean, it's skewed differently in different countries and different demographics and things like that. So some people might have sites that are a lot more Safari heavy, but generally it might be half of your user base, and we can give that value to people today. We can give that improvement to half of the web, if not more. So yeah, I don't think people should be sleeping on this at all. I completely agree there. So guys, thank you so much for your time. I just want to say congratulations as well. I know this has got to the it's become an official RFC under the IETF, which I know was probably a difficult journey to get through. But that's a massive milestone for this project. So congratulations on achieving that.
Thanks, and thanks for having us. It's always fun to talk about.
Yeah. Thank you.
Pleasure. Cheers, guys. If you enjoyed this interview, I already have a few more lined up to talk through other exciting web platform features and APIs with the people working on them. So please subscribe to the YouTube channel, or there's email and RSS options at lessonsofacto.com.